Yes, class. Good evening, class. Am I audible to all of you? Yes, hello, class. Is it audible? Okay. And others as well, apart from
Yes,
ML?
ma'am.
Okay.
Yes,
So,
ma'am.
class, we had stopped at this point. We couldn't complete the second case of astronomical telescope. No, that was when final image was formed at infinity. So, this is simple. We had done simple and compound microscope. This was just left. So, see, same thing. If it is formed at infinity, so now what will happen? The final image will be formed at infinity like this. This will be the case. And this becomes A dash, B dash. This is how the final image will be formed. So again, obviously, UE will be equal to FE. UE will be equal to FE. Because if the final image is formed at infinity, your object distance becomes equal to focal distance, focal length. That is, the object is kept exactly at focus. And here our object is the intermediate image that is formed. Now, see, for magnification, same steps you have to do till here. See, no need to do not to perform all these steps. It's just that B dash E in this case, the meaning of B dash E is different. B dash E is now minus FE. So your magnification becomes minus F naught by FE. This is just the difference that will come. Earlier we had 1 plus FE by D, no? That whole term is not present right now. You just have this term. Fine, note down this point, then we'll complete Prism.
Could you scroll up?
Done this part?
Yes, ma'am.
Done, class? Any doubts you have till here? Optical instruments, all the three portions that we had covered. Microscopes, we did both types. Simple microscopes we had seen, compound microscope we have seen. I hope you all remember the magnifications formula. And again, class, no need to apply sign convention in any of the questions of optical instruments. If you're using a formula that is not a part of optical instrument, like if you're using lens formula, by chance in some question you require lens formula, then to apply proper sign convention in lens formula. But whenever you're substituting it for magnification, then no need. Then last topic that was left was prism. Okay, class. See, prisms are basically wedge-shaped portion of transparent refractive medium. Basically, this means, see, you have two triangular portions. We are able to observe this triangular portion, right? Apart from this triangular portion, there is presence of rectangular parts as well. Like this is what we actually just see. But see, there are actually coverages of the rectangular planes, rectangular glass planes like this, one here, one on the other side, one at the bottom. So this shape is known as wedge. Wedge is basically where you support mainly things. Like you support knife in your 11th standard in laws of motion also, wedge you have been using it. So prisms are basically wedge-shaped portion of transparent refractive medium bounded by two plane surfaces. So these are the refracting surface. This is the refracting edge. This part that you see, this is the refracting face. That's why we'll just focus refracting faces. So we'll be just focusing on the inclination of these. And the angle that is bounded by both these refracting planes, this is known as angle of prism. So this angle can be any angle. If it's an equilateral prism, means all these sides, these are equal, then this angle will be 60 degree because all the angles are 60 degree in that case. So prism is what? A wedge-shaped portion of transparent refractive medium bounded by two plane surfaces inclined to each other at a certain angle. You have refracting faces. This part is known as refracting edge. This part. This is known as refracting edge. Then you have this is the principal section which looks triangular. This is the principal section, and these are the refracting plane surfaces. So in general, when we'll be doing the derivations also, no, right now only. Let's start with the derivation. So when we'll be doing the derivation, when we'll be deriving rest of the phenomena and the variation of angles and incidence ray and the wavelength that are occurring, we'll be just drawing this triangular part. So do not get confused that prism is 3D triangle. Like, it's not like a pyramid, it's like a wedge. It is assumed that prism is just like a pyramid. No, 3D form of triangles, 3 triangles joined together. No, it is proper wedge shape. You must have used it in your practicals as well. You have your angle minimum deviation and the graph plotting in your practicals. So this is a prism. Fine. This is, let's say, this is the front side of the prism where we are taking. So incident ray at this surface, here light ray is incident. This is the incident ray. It got refracted and then again it got refracted. Final ray that emerged, we can call it as the emergent ray also. You can keep it as the refracted ray also. Now see, at this point, if you go into the details, you'll notice that this is a normal. Same way here also. If you'll notice, this is the normal that is formed N1, N2, right? So this becomes the angle of incidence, whereas this becomes first angle of refraction. Let's name this as R2. So this will be the final emergent angle through which the ray has gone out. All right. Now C class, if there wasn't any prism and this incident ray was just flowing, which was just moving, assuming that there was no prism, what would have been the path of the incident ray? It would have gone straight like this, right? If there was no prism, no refraction, no deviation would have occurred. Now, how much deviation has occurred? This much deviation has occurred. So this is the angle by which the ray has actually deviated. This delta, this is known as angle of deviation. Now, if different incident ray falls upon this prism, different angles of deviation you will have depending upon the angle of incidence, right? So one value will be there, which will be the least among all the values. That least or minimum value, you call it as the angle of minimum deviation. So angle of deviation is normal deviation of incident ray from the refracted ray. But angle of minimum deviation is the case through which when you plot the graph between angle of deviation and angle of incidence, you see one point where angle of deviation has its minimum value. In your practicals, you will observe a bell-shaped, opposite U-shaped curve. So here, this part will be delta minimum. Here you will be having angle of incidence value. That is part of your practical, so you will be doing it in your practicals. Apart from this, angle of the prism will be there, this A. So let's name this something A, B, C, D. Let's name this something. Now C class. If you, this is a proper quadrilateral. When you draw this normal straight, that you get ABCD as a proper quadrilateral firstly. Secondly, C class, if you look at this triangle, if you look at this quadrilateral ABCD, then this angle, let's say this is some X angle, this is some X angle. So R1 plus R2 plus this X is equal to 180 degree using ASP angle sum property. So R1 plus R2 will be equal to 180 degree minus X. Fine. So this is one thing that we have. If you look at in this quadrilateral that you have A, B, C, D, opposites angle have their sum as 180 degree. So this will be angle A plus X will be equal to 180 degree. So angle A is what? Angle A is 180 minus X again. It means if you substitute the value of 180 minus X from here, you get R1 plus R2 equal to A. This is one very important equation that is needed throughout your calculation, that angle of prism is the sum of both the refracting angles that are present within the prism. Fine, R1 plus R2 is equal to A. Now, C class, let's name this angle. Now, let me zoom it so you can notice here. C class, this angle I'm calling it as angle 1 and this angle I'm calling it as angle 2. So can any one of you tell me what is this total angle equal to?
180.
Not 180. This angle. Look through the figure. Is it equal to something?
45.
Angle of incident.
Angle of incidence. Angle of incidence. Correct. See, angle of incidence. This is angle of incidence. So this will also be no angle of incidence. Vertically opposite angles. These are just intersecting lines. See here. These are intersecting lines. Over here, look. Similarly, if this entire angle is angle of emergence, so this entire will also be angle of emergence, right? So I can say angle 1 plus R is equal to this angle of incidence, and 2 plus R2 is equal to angle of emergence. So this is just because they are vertically opposite angles. Now see here. If you have such case, I can write 1 plus R1 equal to angle of incidence. From here, I can write 1 as I minus R1. Same thing for angle of emergence. If I write angle 2 plus R2 is equal to E. So angle 2 will be equal to E minus R2. Now look at this triangle that is formed between B. You can name this point as something. Let's name this point as N. Look in the triangle MBD, this triangle that has been formed. So if you use exterior angle property says what? Opposite sum of all the opposite angles is equal to the exterior angle of the triangle. It means angle 1 plus angle 2 is equal to delta. So now put in the values of angle 1 and angle 2. Angle 1 and angle 2 we have already kept aside. So just keep the value. So your delta will be equal to 1 is I minus R1 plus R2. R2 is plus E minus R2. So keep R1, R2 together. I plus E minus R1 minus R2. I plus E. Take minus sign common. R1 plus R2. Just now, didn't we calculate? R1 plus R2 is equal to A. So delta is equal to I plus E minus A. A is the angle of prism, I is the angle of incidence, E is the angle of emergence, and delta is the angle of deviation. This is the general case. Till now, we haven't calculated the minimum deviation, which I was referring. You can get normal deviation also. So angle of deviation is sum of angle of incidence and emergence subtracted from the angle of the prism. This is the equation. So angle of incidence plus angle of emergence is equal to angle of prism plus angle of deviation. You can write this as this also, no? Del A plus delta is equal to I plus E. This way also you can use it. But main equation is this for deviation. Now, if this is the case for minimum deviation class, if this is the case for angle of minimum deviation, just remember and add two quantities. Just remember and add two conditions, not quantities, just two conditions. R1 becomes equal to R2 firstly. Second, angle of incidence becomes equal to angle of emergence. These are two cases for minimum deviation to occur. This is from a theory point. that angle of incidence is equal to angle of emergence and R1 is equal to R2. Now, how have they been calculated? Why are we directly using? It's just because of experiment. Experimentally, they have been derived. When you do the experiment also, no, by yourself, in your practicals also, it is included. So that time also you notice that yes, angle of incidence becomes equal to angle of emergence. And especially students who will get this experiment in their exam, they have to be prepared thoroughly with this prism and dispersion of white light part, because external examiner asks mainly questions from here. Okay, coming to the condition. So see, if R1 plus R2 is equal to A, right, this was, so it means we can substitute 2R is equal to A. So R becomes equal to A by 2. Instead of writing R1, R2, we can write it like R only here. There's no difference over here. Now coming to the other formula which we had concluded, that was delta. So delta is equal to I plus E minus A. So from here I can write delta is equal to 2I minus A, because I plus E both are same. I and E, these are equal. This was the second condition. So 2I will be equal to delta plus A. Angle of incidence will be equal to delta plus A by 2. So I have angle of incidence with me. I have angle of refraction with me. See class, if these two quantities are known to you, just apply Snell's law. Snell's law is sine I by sine R. So refractive index, this will be equal to sine I. I is delta plus A by 2 divided by sine R. This is sine A by 2. So this is the formula. This is the formula that you use. Angle of minimum deviation. All right. So these are actually done through the help of spectrometer. So no need to go into those details. You just have to remember this formula. You have to remember this line, delta is equal to I plus E minus A. And the derivation comes a lot in your exam, and do mark this derivation as important. This derivation does come in your paper. So note it down. Wherever you are having difficulties, wherever you are having any query, just ask me. Start noting it from here. Do the derivation part and we'll come to the numericals.
Ma'am, can I scroll up? Yes, ma'am, done.
Done, all of you?
Yes, ma'am.
Yes, ma'am.
Okay, let's practice one or two questions. And one case we have to see in this, that we'll see. But first, let us practice one question. See, this question says that calculate refractive index of material of an equilateral prism. So if it is mentioned equilateral prism, what should be angle of deviation? What should be angle of prism?
60.
60 degree.
Yes, it will be 60 degree. For which angle of minimum deviation is given as 60 degree. So both the angles are 60. A is 60, delta is 60. You have to find out refractive index. See, refractive index formula. This is sine del plus A by 2 divided by sine A by 2. So if you substitute in here, this is sine 60 plus 60 by 2. And over here, it will be just 60 by 2. Just keeping the values of del and A from here. So n will be, see, 120 by 2, that is 60. So sine 60 degree. And sine 60 by 2, that is sine 30 degrees. So here you have root 3 by 2. Here you have 1 by 2. So refractive index will be root 3. Yes, good enough. Correct. Root 3. Note this down. One more numerical beat. C class, the second question says that a ray of light passes through an equilateral prism such that angle of incidence is equal to angle of emergence. Now, an angle of emergence is given that this is 3/4 of angle of prism. So do we have any information of the angle of prism? Yes, it is an equilateral prism. So A will be equal to 60 degree. If A is 60 degrees, so E will be 3/4 into 60 degree. Directly we can write this. So 15, that will be 45, right? So E is equal to 45. If E is 45, I will also be equal to 45 degrees because I and E are same. So angle of deviation, the refractive index of prism. See, delta can directly be calculated from this statement only, I plus E minus A. So delta will be 45 plus 45 minus 60. So that is 90 degree minus 60 degrees equal to 30 degrees. Correct. Ahmed, calculate the second part as well. Now you have delta, you have A, you just require these simple things only for angle of refraction, refractive index of prism. So N will be C class sine delta plus A by 2 by sine A by 2. So refractive index, this will be, this is 30 plus 60 by 2. Sine will also come now. So sine 30 plus 60 by 2 by sine A by 2, and A is 60 degree because this is an equilateral prism. So 60 by 2. Anyone who is having any difficulty want me to repeat, please interrupt in between. So 60 plus 30, 90 by 2, that is 45. So sine 45 by sine 30 degrees, right? So this will be equal to N is equal to sine 45 is 1 by root 2. Sine 30 is half. So 2 by root 2 you can raise, and if you want to rationalize it, multiply and divide it by root 2, you will get your answer as root 2.8. Is it clear? Simple usage of these formulas. Are these clear to all of you?
Yes, ma'am.
Yes, ma'am.
Alan, Aryan, Jiva, Mariam, to you also?
Yes, ma'am.
Okay. So note down the solution. If anybody has not written the question, let me know. I'll scroll up for the question.
I'm pretty sure the question.
Okay. Now see, if the angle of the prism, this is very narrow, it means, see, both the refracting planes, the rectangular planes that you have, if they are kept at a wider distance, that will lead to formation of a wider angle. If they are kept narrower, that will lead to formation of a small angle, like this. If these are kept too close to each other, this angle, this will reduce. If you have small angle, constantly we have been using small angle approximation. So here also we'll be using small angle approximation as well, class. Understood? Small angle approximation will again be used for this as well. Now see, you have the main equation, delta is equal to I plus E minus A. See, class, if you apply Snell's law at this point, first point, let's say this is first point. If you apply Snell's law at P, let's say this point is P, P, Q, R. Fine. So you will write this as 1 into sine I is equal to N into sine R. So on using small angle approximation, you can write this as I is equal to NR only, because when you use small angle approximation, sine theta is almost equal to theta. This I have told you several times. Sine theta becomes equal to theta and tan theta almost becomes equal to theta. So both these angles become equal to whatever is the value of angle given. Same way, same will be applied for E also. Angle of emergence also that has arisen out of the prism, right? For same thing it will be applied. So E, this will also be equal to N R2. This is R1, you can take that, you can take it as R2. Now put it in the formula. So this is equal to N R1 plus N R2 minus A, correct? So let's take angle of refraction, not angle of refraction. Let's take N common, refractive index. So N becomes equal to R1 plus R2 minus A. What is R1 plus R2, class?
A.
A. Good, Ahmed. This is equal to A. R1 plus R2 is equal to A. So delta is N. Instead of this, I'm writing A minus A. Take A common, you get A N minus 1. This is the formula that you use in case of small angle prism. So we call the prism only a small angle. And in your exam, you can get a question like derive an expression for the angle of deviation of a small prism in terms of refractive index and angle of prism. So you have to derive this relation if such a question arises. Then you have very small topics left like angular dispersion, dispersive power, Kachi's formula, and dispersion and all. So do this, then we'll wrap up the lesson by those theoretical topics that you have. Note this down. see, when we study the phenomena of dispersion, of various basic things are there. There's the relation that we have to understand between the refractive index and the wavelength of the radiations that are passed through, or the white light. See, white light is made up of 7 colors. That, let's do it. But before that, no, there's one formula that is known as Cauchy's formula. So in this, no, this is refractive index. It shows that the refractive index is equal to sum of A plus B by lambda plus C by lambda square plus D by lambda cube plus E by lambda to the power 4 plus F by lambda to the power 5 and so on. Now, what are these ABCDs? ABCDs, these are just constants, and the values of which depend on the nature of the material. But this formula is essential for your application part and your theoretical questions. Refractive index becomes inversely proportional to wavelength. This is one thing that is needed. Now, see class, just for using this, how many things you can derive? Look here. Wavelength of red, and there's a huge comparison that you'll observe between red and violet. So please remember that red has the highest wavelength and violet has the least in the whole spectrum of Vibgyor that you obtain. So if red has the highest wavelength, refractive index of red will be the least and violet will have the highest. Now see a formula we did for small angle. Delta is equal to n angle of prism minus 1. A n minus 1. This is equal to here A n minus 1. So you can see refractive index and angle of deviation both are directly proportional to each other. So if you have come to this conclusion, you can even conclude the fact that delta R is less than delta V, because whatever will happen to refractive index, same thing will happen to angle of deviation. See class, all these parts you'll get in theory part, that compare the relation, which one, like you'll be getting all these out of these, let's say this and these 4, indigo, yellow, orange, red has been provided, and the question is asking you to compare the angle of deviations. So you will go by the wavelength only. Red has the highest wavelength. So if it has the highest wavelength, it will be having the least angle of deviation. Then will come orange, then will come yellow, then will come indigo, like this. So such questions will be there. One more thing, it can also be asked to you in terms of velocity. Refractive index, see, speed of light is equal to wavelength into frequency. So wavelength and velocity both are directly proportional to each other. So velocity will go in hand with whatever conclusions you will be obtaining it for the wavelength. So velocity of light. So these are some points that have to be noted in terms of your Cauchy's formula. From your Cauchy's formula, such questions are only possible. Now, one phenomena you have that is known as dispersion. Let us first come to this dispersion phenomena. See, just understand this part. Rest of the writing part you can do. Everything has been kept. This is a prism. Now you have white light present, the whole complete white light. This light, you call it as white light. Now this white light is made up of all the 7 colors, which you call as the Vibgyor. All these 7 colors are clubbed together. Whenever they are mixed, you get the light, which you call it as the white light. Right? Whenever this white light is incident on a medium, let's say it is incident on a medium, this medium is prism. So what will happen? It will get refracted and it will spread into all the 7 colors that are present. All these from here, violet, then indigo, till red color. All these colors will be present like this. All the colors will be present. So this phenomena of splitting of white light, this is known as dispersion. But see here, the material See, the material that will allow dispersion to occur. Like here when this incident ray passed through it. So what happened? All the colors dispersed in this medium. So it means prism allowed this to occur. Prism allowed the white light to get split. This was white light that was present. So prism allowed it. So it means we call prism, this is known as a dispersive medium. This is known as a dispersive medium. Now see, let's talk about non-dispersive medium. Let's say air. If air is present, here white light is present, some amount of white light is present at this point. Now see, when this white light is passing through air, is it getting dispersed? No, until and unless it passes through a material like prism, it won't get dispersed. So for such materials like air, you do not have any dispersion occurring. Otherwise, everywhere you will be seeing rainbow formation. So such types of medium like air, these are known as non-dispersive medium. So dispersive medium, non-dispersive medium, and the phenomena of dispersion. Now come to the definitions. Dispersion, the phenomena of splitting of white light into its 7 colors on passing through a refracting medium is called dispersion. And yes, the band of colors that you obtain, this WIBGYOR, this is known as spectrum. Then medium that allows dispersion to occur, or you can say where the colors travel with different speeds, like glass, prism, and all these. So that is dispersive medium, and where different colors travel with the same speed. And it basically does not allow dispersion phenomena to occur, like air. You call that medium as a non-dispersive medium. Now, apart from this dispersion and dispersive medium, you have angular dispersion and you have dispersive power. These are two quantities that you just have to understand. There is a comparison between violet and red color. So see, between red and violet, there's a comparison. So you have to analyze it. Like for red color, if we write it. So angle of deviation for red color. So it will be refractive index of red color, angle of prism -1, refractive index of violet color, angle of prism -1. Like this, for individual colors, you can write this individually. So now see what is meant by angular dispersion. Angular dispersion is the difference between these two angles. Angular dispersion is actually difference between the angle of deviations of the two extreme colors, not any two colors. Don't consider like you can take it for green or yellow or orange or indigo, any other color. No, just for the two extreme colors. So that makes it delta violet minus delta red. This is what is meant by angular dispersion, difference between the angles. Now, apart from this, this was angular dispersion. You have one mean deviation. Mean deviation. Mean deviation is when you take the mean of these extreme angles, like delta R plus delta violet divided by 2. So here in this case, you get the mean value. Whenever we have the mean value, no, for red and violet, if you take, you will get every data for yellow color. Now coming to what I was telling you, angular dispersion and dispersive power. What is meant by dispersive power? See, dispersive power is ratio of two things. It is firstly the ratio of angular dispersion, secondly, mean deviation. So dispersive power is angular dispersion by the mean deviation. Understood? So if you put in the formula, dispersive power is usually represented through the symbol omega. We have no W, this omega. See, angular dispersion is difference between both the extreme colors, that is delta violet minus delta red. And mean deviation. Mean deviation, either you can write this complete formula or directly you can write it for yellow. Yellow color you can write it. see, this becomes, if you write this, and this will become it for the yellow. So see, this will be, if you write it, refractive index of violet -1. Let me show. If you apply this, see what you will be left with. For this part, you can write it as NV -1 into A minus NR -1 into A, right, divided by N yellow -1 into A. Correct. Now see, just expand it. So omega will be equal to, from here, see, when you'll open up the brackets, you will be left with A will be there. 1 will get cancelled. No, so you will have NV minus NR into A. 1 will get cancelled, +1 -1. And here you will have N yellow -1 into A. Angle of prism gets cancelled. Dispersive power becomes NV minus NR by NY minus 1. This is dispersive power, where this is refractive index of yellow color. This is the phenomenon of dispersion, dispersive power, dispersive medium, non-dispersive medium, and Cauchy's formula. All are related to each other. This is just one single topic. So is it clear to all of you? Yes, understood.
Yes, ma'am.
Only Aryan? What about others? Clear or not?
Yes, ma'am.
All right, then note it down. Any difficulty you have it, please let me know. Whatever queries you have, you can text me also. You can ask me directly as well. Yes, completed all.
Yes, ma'am.
All of you open up your video cameras. 3 questions are there. 2 numericals. Middle one is the theoretical portion completely. Apparent depth and TIR, I had told you that I'll take the test. So start with the test. And again, I'm repeating the way we had the last test. Although all of you have to open up your cameras and begin with the test. Already focus mode has been started. So Zaid, Astha, Ahmed, and Jiva, only their papers are under consideration now. Mariam, Alan, Rehan, let me know from your side as well. Alan, set your camera properly. Mariam, I'll share my number with you. If you are not added on the group, then send it to me personally. Otherwise, Mariam, send it on the group if you're added. I'm sharing my number also. Okay, you're not added, no? So I have shared my number. So you can directly convert it into the PDF, whatever pages you have taken, and click the pic and send me.
Ma'am,
Yes, Asta.
ma'am, for the third question, the medium is not specified. So it's like vacuum or air.
For the third question, calculate the speed of light in a medium whose critical angle is 30 degree. So you have to find out speed of light in a medium whose critical angle is 30 degree. That medium is unknown to you. Medium
s-
is not given. Just focus on critical angle. Using critical angle, calculate rest of the things.
Okay, ma'am.
How many hints for the third question?
CZ. For the third question, no, all of you know the formula for critical angle. Critical angle, you know, using critical angle, refractive index, indices formula. Refractive index formula you have, multiple formula you have, where one medium you can take it as the air or vacuum. Other medium is the medium that is given in the question. So using that, find out the speed. Take one medium as this medium and take second medium as the speed of light which you take. And then you have refractive index, you have critical angle. Relate all the three.
Ma'am, I'll scan and I'll send it in the group.
Yes, Astha?
Ma'am, my test is over. So should I send it in the group?
Yes, submit your PDF on the group. And then you can leave after submitting. Others also, 10 minutes are left.